All right, this is 2013 AP Calculus BC exam, question number 6 again, yet another Taylor series question. And on this one, I think you're going to find part A is really tricky. If we can get through part A, part B and part C are not too bad at all. So let's read through this and see if we can make some sense out of it. A function f has derivatives of all orders. No big deal there. All orders just means it makes sense to talk about the third derivative or the fifth derivative or something like that. At x equals 0 is helpful. We're going to make this at 0. So it's a Maclaurin series. So that's kind of nice. P sub n denote the nth degree Taylor polynomial. We've used this notation before. So P sub 3 would be the third degree, or P sub 5 would be the fifth degree, or whatever. So no big deal on that. Standard notation. Denote the nth degree Taylor polynomial for f about x equals 0. Okay, I got the point. X equals 0. So we're making this at 0. Okay. Part A is the trickiest part. Let's see if we make sense out of this. And it's tricky because they're asking it kind of backwards from what we're used to doing the problem. So here's part A. It is known that our function at 0 is negative 4. We'll need that. And that p of a half is negative 3. Slightly strange that they give that to us like that. So that means when they put in x as a half into their first degree Taylor polynomial, they're getting out a value. So p of 1 is negative 3. And from that information, they would like us to show that the first derivative at 0 must be 2. Okay, kind of two approaches to this. I'll show you what I think is kind of the standard approach. It's very possible you might have a different approach that's also true. Like I say, there was two very correct solutions. There might even be more than that. But two for sure on the AP that I know they accepted. Okay, let's make a Taylor polynomial. Let's make it of order 1. There's a formula for this, and you should know this formula. It's not a big deal. What's the formula for the Taylor polynomial of order 1? Well, it'd be the function at 0. It'd be the first derivative at 0. It'd be x to the first over 1 factorial. That's our formula for a Taylor polynomial. We're making it at 0, so we put in a 0 for the function and a 0 in for the derivative. Okay, we look back up here. They tell us right here, f of 0 is negative 4. So we've got that. They don't tell us f prime. We're supposed to show this thing. So my approach would be, let's just leave that as an unknown. And we've got this polynomial. I didn't really have to write over 1. And over here, here's my polynomial. Okay, it's negative 4 plus f prime of x at 0 times x equals p sub 1 of x. Okay, now we use this piece of information. Again, it's backwards because we're so used to them telling us all the derivatives. But they didn't. P of 1 of a half. So when x is a half, my polynomial should be 3. So I'll sub in those values. So let's see. P1 I should get out of 3. And for x, I put in a half. Let's see if we can solve this. I'll add on 4 to both sides. So 1 equals f prime of 0 times a half. Or, just follow that up here, I guess. F prime of 0. That's a 0. F prime of 0. Multiply by the reciprocal of a half. So multiply by 2. And f prime of 0 equals 2. There. I've shown it. Okay, and I think that is the biggest trick in this problem, is that part right there. Now let's do part B, let's do part C. And I want to erase the part that's up here just so I don't have to keep scrolling up or down. But we'll use part A in part B, and we can use it in part C as well. So we'll want to keep in mind these values, which we see in part A. So let's just get this out of here. Let's just clean this up here too a little bit. And now let's do part B. So if you can get through part A, it gets a little easier. All right, part B. It is known that the second derivative is negative 2/3. The third derivative is 1/3. Find P3 of x. Wait, that's easy. That's my function at 0. My first derivative at 0. X to the first over 1 factorial. My second derivative at 0. X to the second over 2 factorial. And my third derivative at 0. X to the third over 3 factorial. That's how you make a polynomial. Just sub in the numbers and we are done. P3 of x. What does it equal? It equals -4 plus. We can use this. We've shown it. Even if you didn't get part A, you can still use this value. So plus 2x plus my second derivative, a -2/3 x squared over 2 factorial. I think we'll simplify that a little bit. And the third derivative is a 1/3 x to the third over 3 factorial. Done. Let's simplify it anyway, because I think we're going to need it in the next part. So we simplify that to -4 plus 2x minus, reduce that fraction, you get 1/3 x squared, plus 3 factorial is 6. So you get 1/18 x cubed. There we go. There's P3 of x. Very, very straightforward. When you look at some of the homework problems you guys have been doing, this is a little bit easier. Maybe it's a lot easier than the homework problems you've been doing. All right, we've got that. Let's do part C now. H prime of x is f of 2x. Let's just do that part right now. This is P3 of x, which is based on f of x. So f of x is, that's the polynomial approximation. So h prime of x equals f of 2x. So guys, everywhere you see an x, take out that x and put in a 2x. So I get a -4, take out the x, just kind of circle that or erase that or something here. Take out the x, put in a 2x, and I get 4x minus 1/3. Take out the x, put in a 2x, square it. I get 4x squared. So let's call that 4/3 x squared. Do the same thing here. Take out the x, put in a 2x, cube it. I get 8 x cubed. 8 over 18 is 4/9 x to the third. There's h prime of x. All right. It is known that h of 0 is 7. Can you find the third degree Taylor polynomial for h? Well, guys, this is h prime. How do we get h? Take the integral. Not too, oops, I was going to try to keep the question. We'll come back and get the question. What's h of x? It's the integral. Again, let's go term by term. Do you know the integral of -4? Sure. -4x. Do you know the integral of 4x? Sure. 2x squared. Do you know the integral of -4/3 x squared? Sure. -4/9 x cubed. And then, do you know this integral right here? Actually, it doesn't matter. Go back up and look at the question. The question was, find the third degree Taylor polynomial. You've written a third degree Taylor polynomial, so don't get carried away and write a fourth degree. You've got this. You've also taken an integral, so don't forget a plus c. Makes the most sense to put the c at the front because your polynomial is in ascending order. You look back at the initial condition. H of 0 was 7. So sub in a 0 everywhere, and you can see the c is 7. So our polynomial is h of x is 7 minus 4x plus 2x squared minus 4/9 x to the third. So this is kind of the expectation for the College Board on these Taylor series. So the formulas you guys have learned, I would say once we get past part A, some relatively straightforward work within those formulas. And that takes care of 2013 BC number 6. And again, hopefully that one makes sense.